Hey everyone, welcome back to the channel. Today we are going to prove that cos A by 1 minus tan A plus sin A by 1 minus cot A will be equal to cos A plus sin A. Now let us take LHS and prove RHS. And in RHS we have cos A and sin A, so that we can change tan A and cot A into sin and cos. Now let's change tan and cot into sin and cos, that is cos A by 1 minus tan can be written as sin A by cos A plus sin A is kept as it is, and 1 minus cot A can be written as cos A by sin A. Now let us take LCM in the denominator. Cos A by cos A minus sin A whole divided by cos A plus sin A by sin A minus cos A whole divided by sin A. Now this cos will be going to the numerator and this sin will be going to the numerator. Then cos square A by cos A minus sin A plus sin square A by sin A minus cos A. Now let us take LCM for the denominators. So we need to convert cos A minus sin A and sin A minus cos A to same number. So that we are taking cos square A by cos A minus sin A. Here we are taking minus as common. Here we are taking minus as common. So cos A minus sin A. Then cos square A by cos A minus sin A. Here minus into plus will become minus. Sin square A by cos A minus sin A. Now we can take LCM. Denominator will be cos A minus sin A. Cos square A minus sin square A. Here it is in the form of a square minus b square. We can write it as a plus b into a minus b, that is cos A minus sin A cos A plus sin A divided by cos A minus sin A, and cos A minus sin A, cos A minus sin A is cancelled. Therefore cos A plus sin A, which is equal to RHS. Move on to next question. 1 by 1 plus sin theta plus 1 by 1 minus sin theta will be equal to 2 secant square theta. By taking LHS, we need to prove RHS, that is 1 by 1 plus sin theta plus 1 by 1 minus sin theta. By taking LCM for the denominator, that is 1 plus sin theta into 1 minus sin theta. In the first term already we have 1 plus sin theta, so we need to multiply numerator by 1 minus sin theta. 1 into 1 minus sin theta will become 1 minus sin theta. In the second term we have 1 minus sin theta in the denominator, so we need to multiply the numerator by 1 plus sin theta. Therefore 1 into 1 plus sin theta will become 1 plus sin theta. Therefore 1 plus 1 will be 2, minus sin theta plus sin theta will be cancelled. Here it is in the form of a plus b into a minus b. Therefore it can be written as a square minus b square. Therefore 1 square minus sin square theta, and we know that 1 minus sin square theta can be written as cos square theta. Therefore 2 by cos square theta can be written as 2 into 1 by cos square theta, and 2 into 1 by cos square theta can be written as secant square theta, which is equal to RHS. Now let's move on to next question. 1 plus sin theta whole square plus 1 minus sin theta whole square divided by 2 cos square theta will be equal to secant square theta plus tan square theta. By taking LHS, we need to prove RHS. In the LHS, we have the form a plus b whole square. It will be equal to a square plus 2ab plus b square, and a minus b whole square will be equal to a square minus 2ab plus b square. So 1 plus sin theta whole square, it is in the form of a plus b whole square. A is 1 and b is equal to sin theta. Therefore, it can be written as a square plus 2 into a into b plus b square, it is sin square theta plus a minus b whole square, a square minus 2ab plus b square whole divided by 2 cos square theta. 1 plus 1 will become 2 plus 2 sin theta and minus 2 sin theta can be cancelled. Sin square theta plus sin square theta can be written as 2 by 2 sin square theta whole divided by 2 cos square theta. Now in the numerator, let us take 2 as common. 1 plus sin square theta divided by 2 cos square theta. 2 is cancelled. Now let us divide the denominator into different parts. 1 by cos square theta plus sin square theta by cos square theta. 1 by cos can be written as secant, therefore it is secant square theta plus sin square theta by cos square theta can be written as tan square theta. Therefore, it is equal to RHS. Now let's move on to next question. 1 plus tan square theta by 1 plus secant theta will be equal to secant theta. By taking LHS, we need to prove RHS. Therefore, LHS can be changed to, now in the LHS, tan square theta and secant theta can be changed into sin and cos. Like 1 plus tan square can be changed to sin square theta by cos square theta, and 1 plus secant theta can be changed to 1 by cos theta, and therefore 1 plus sin square theta by cos square theta. In the denominator, we are taking LCM, that is cos theta plus 1 by cos theta, and it can go to numerator, and this cos theta will be sent to the numerator, that is 1 plus sin square theta into cos theta divided by cos square theta into cos theta plus 1. Therefore, 1 cos and 1 cos in the numerator and denominator will get cancelled. Therefore, 1 plus sin square theta can be taken as 1 minus cos square theta divided by cos theta into cos theta plus 1. And in numerator, we can note that a square minus b square can be written as a plus b into a minus b. Therefore, 1 plus cos theta into 1 minus cos theta divided by cos theta into cos theta plus 1. 1 plus cos theta plus 1 will be cancelled. 1 plus 1 minus cos theta divided by cos theta. Here we need to split the denominator, that is 1 plus 1 by cos theta minus cos theta by cos theta. Cos theta by cos theta will be cancelled. Therefore, plus 1 by cos theta can be written as secant theta minus 1. Plus 1 minus 1 is cancelled. Secant theta will be left out, which is our RHS. Now, let's move on to next question. Cos A by 1 plus sin A plus 1 plus sin A by cos A will be equal to 2 secant A. Here we need to prove that LHS will be equal to RHS. By taking LHS, now in LHS we need to take LCM, that is 1 plus sin A into cos A. Here in this first term we already have 1 plus sin A, so we need to multiply with cos A. Therefore, cos A into cos A will become cos square A, plus here we have cos A already, so we need to multiply with 1 plus sin A. 1 plus sin A into 1 plus sin A will become 1 plus sin A whole square. And in the numerator, cos square A can be written same it is, but here A plus B whole square, therefore A square plus B square plus 2AB, and in the denominator 1 plus sin A into cos A. Now cos square a plus sin square a will be equal to 1 by trigonometric identity. 1 plus 1 plus 2 ones are 2, 2 sin a divided by 1 plus sin a into cos a. In the numerator 2 can be taken out to 1 plus sin a divided by 1 plus sin a by cos a. 1 plus sin a, 1 plus sin a can be cancelled. Therefore, left out will be 2 by cos a and 2 into 1 by cos a, and 2 into 1 by cos can be written as secant a. Therefore, RHS is proved. Now, let's move on to next question. Under root secant square theta plus cosecant square theta will be equal to secant theta into cosecant theta. By taking LHS and replacing secant and cosecant into sin and cos. Secant square theta. Here, secant square theta can be written as 1 by cos square theta plus cosecant square theta can be written as 1 by sin square theta. Now, by taking LCM, sin square theta plus cos square theta whole divided by cos square theta into sin square theta. We know that sin square theta plus cos square theta can be written as 1 by cos square theta sin square theta whole under root. Now, root squares can be cancelled out. Therefore, 1 by cos theta into sin theta. This can be changed to 1 by cos theta into 1 by sin theta. Therefore, we know that 1 by cos theta can be changed to secant theta into 1 by sin theta can be changed to cosecant theta. Therefore, it is our RHS. Now, let's move on to next question. Under root 1 minus sin a by 1 plus sin a will be equal to secant a minus tan a. We need to prove LHS is equal to RHS. Here in the LHS form we have square root. Therefore, let us perform rationalizing the denominator. In the denominator we have plus symbol. So, let us rationalize it by minus. Therefore, under root 1 minus sin a by 1 plus sin a into 1 minus sin a by 1 minus sin a. Numerator is in the form a minus b into a minus b, that is a minus b whole square. In the new denominator 1 plus sin a into 1 minus sin a, it will perform a square minus b square. Let's split the square root to numerator and denominator. And 1 minus sin square a can be written as cos square a. Square, square root can be cancelled. So, 1 minus sin a by cos a. Split the denominator, 1 by cos a minus sin a by cos a. 1 by cos a can be written as secant a minus sin a by cos a can be written as tan a. It is our RHS, hence proved. Now, let's move on to next problem. 1 plus cos a by 1 minus cos a will be equal to cosecant a plus cot a whole square. By taking LHS, we need to prove RHS, but by taking LHS, we can't prove RHS. So, for this, we need to take 1 plus cos a by 1 minus cos a rationalization method. Therefore, it is having minus, so we need to rationalize it by plus 1 plus cos a by 1 plus cos a. Numerator 1 plus cos a into 1 plus cos a can be written as 1 plus cos a whole square by a minus b into a plus b can be written as a square minus b square, that is 1 square minus cos square a. The numerator is kept as it is, and in the denominator 1 minus cos square a can be written as sin square a. Now, we are taking the square as whole, that is 1 plus cos a by sin a whole square, and splitting the denominator, that is 1 by sin a plus cos a by sin a whole square. 1 by sin a can be written as cosecant A plus cos A by sin A can be written as cot A whole square, which is our RHS. Now let's move on to next question. Under root 1 plus sin A by 1 minus sin A minus under root 1 minus sin A by 1 plus sin A will be equal to 2 tan A. By taking LHS, we need to prove RHS. In the LHS, we are having square root, therefore we need to rationalize the denominator. So by taking LHS, 1 plus sin A by 1 minus sin A. In the denominator, we are having 1 minus sin A, so we need to rationalize by 1 plus sin A by 1 plus sin A minus 1 minus sin A by 1 plus sin A. In the second term, we are having 1 plus sin A, so we need to rationalize it by 1 minus sin A by 1 minus sin A. Numerator can be written as 1 plus sin A whole square divided by A square minus B square, that is 1 square minus sin square A, under root minus under root 1 minus sin A whole square divided by 1 square minus sin square A. In the denominator, we can change 1 minus sin square A into cos square A. Therefore, 1 plus sin A whole square by cos square A minus under root 1 minus sin A whole square by cos square A. Square root and square root will be cancelled. Therefore, 1 plus sin A by cos A minus of 1 minus sin A by cos A. Now the denominators are same. Let us take LCM. Cos A 1 plus sin A minus of 1 minus sin A. Therefore, 1 plus sin A into, we are multiplying with minus symbol, that is minus 1 plus sin A divided by cos A. Plus 1 and minus 1 is cancelled. Sin A plus sin A will become 2 sin A by cos A. 2 into sin A by cos A can be written as tan A, which is equal to RHS. Hence proved. Now let's move on to next question. Under root 1 plus cos A by 1 minus cos A plus under root 1 minus cos A by 1 plus cos A will be equal to 2 cosecant A. It is similar to the previous problem. So let us rationalize the denominator for the LHS. That is 1 plus cos A by 1 minus cos A into 1 plus cos A by 1 plus cos A plus 1 minus cos A by 1 plus cos A into 1 minus cos A by 1 minus cos A. It can be written as 1 plus cos A whole square divided by 1 square minus cos square A plus under root 1 minus cos A whole square divided by 1 square minus cos square A. Therefore, 1 plus cos A whole square divided by 1 square minus cos square can be written as sin square A plus under root 1 minus cos A whole square by sin square A. Now let's cancel square and square root. Therefore, 1 plus cos A by sin A plus 1 minus cos A by sin A. Now let us take LCM. Sin A 1 plus cos A plus 1 minus cos A. Plus cos A minus cos A can be cancelled. 2 by sin A and it will be equal to 2 into 1 by sin A can be written as cosecant A, which is equal to our RHS, hence proved. That's it for today. I hope you find this helpful. If you have any questions, leave them in the comment below. And don't forget to like and subscribe for more videos. Thanks for watching.